Okay, let's go look at the review for exam 2. Question 1 says to graph the parabola and the axis of symmetry. Use the dashed line to indicate the axis of symmetry. Label the coordinates of the vertex and write the equation of the axis of symmetry. Use the graph to write the domain and range in interval notation. Whoops. Okay, so the function is y equals x minus 1 squared plus 3. Okay, the x minus 1 means the vertex, instead of being at the origin, is going to go to the right 1, and then the plus 3 out to the side means that it moves up 3. So instead of being here at 0, 0, the vertex is going to be at 1, 3. Now to graph this on using ALEKS, you have to go grab the parabola tool and click on 2 points. So 1, 3 is a point, and now if we plug in 0 for x, what do we get? So y would be 0 minus 1 squared plus 3. So negative 1 squared is 1 plus 3, which is 4. So here's a second point, and the parabola would look something like this. All right, now you're supposed to graph the axis of symmetry with a dotted line. So you would go grab the dotted line over on the side tool, and you would click 2 points. I would click here on the vertex and then just go somewhere up above it. So here's the axis of symmetry. All right, now let's go see what it wants us to tell it. The vertex, we already saw the vertex was right here on the parabola at 1, 3. The equation of the axis of symmetry. It's a vertical line always going through 1 on the x-axis, so it's going to be x equals 1. The interval notation for the domain, what x's can you plug in? It's all real numbers. Every parabola, the domain is always all reals. Now for the range, those are the y values. The range starts here at 3. It can be any y value bigger than 3, but it starts at 3. So how do we say y has to be bigger than or equal to 3 in interval notation? We say 3 to infinity. Make sure it's a bracket on 3 because it can be 3. For number 2, find the vertex of the parabola by applying the vertex formula. The function is y equals 3x squared minus 48x minus 91. Now you're looking for h comma k, the vertex. So the x value of the vertex, the x, is always negative b over 2a. So b is negative 48. So negative b is going to be positive 48 over 2 times 3. Here's your a. Okay, 48 over 6 is 8. Now for your k value, you're going to plug in 8 everywhere you see an x. And when you do that arithmetic, you should get negative 283. So the vertex is the coordinate 8, comma, negative 283. Number 3, the monthly profit for a company that makes decorative picture frames depends on the price per frame. The company determines that the profit is approximated by that formula, where P is the price per frame and F of P is the monthly profit based on that price. Find the price that generates the maximum profit. Some things to point out. You see that's a negative 80 P squared? So that's going to be a parabola that opens down because A is negative 80. So you're looking for the vertex, the maximum profit, and the price that would give you that maximum profit. Okay, so the x value, or the h value, is going to be negative b over 2a. So we get negative 2560 over 2 times negative 80. And when you do that on your calculator, you get 16. So the price that generates the maximum profit is $16 per frame. Now it wants you to find the maximum profit. I'm going to do that one in red. To find the maximum profit, so f of 16 would be negative 80 times 16 squared plus 2560 times 16 minus 17,600. And when you do that arithmetic, you get 2880. So the maximum profit would be 2,880. And the last part, part C, says to find the prices that would enable the company to break even. If there's more than one price, use the AND button. Okay, so break even means the profit is 0. So when would 0 equal negative 80? I'm going to use x's because the p's kind of confuse me. Negative 80x squared plus 2560x minus 17,600. Okay, remember on our calculator, we've got apps, and then down at number 9, we're trying to find a root, right? Polynomial root finder. So number 1, it's a second order because it's x squared. So I'm going to go next, which is above the graph button. I have negative 80 for my A. And then I have, I'm going to go look again. What was negative 80, 2560, and negative 17,600. Okay. Plus 2560 minus 17,600. Is that right? Yes. Okay. Then I'm going to hit solve above the graph button. So I get x equals 10 and x equals 22. Okay, if you were doing this by hand, I would factor out a negative 80. So I'd have 0 equals negative 80 times x squared minus, okay, 2560 divided by 80. 2560 over 80 gives me 32. And then plus 17,600 divided by 80 is 220. Okay, now that second degree polynomial will factor to x minus 10 and x minus 22. I get x squared minus 22x minus 10x is minus 32x plus 220. So I get x equals 10, x equals 22. Hey, number 4, determine the end behavior of the graph of the function. The function is k of x equals 17x to the 7th plus 9x squared plus 8x minus 6. Remember that the shape of a polynomial is dominated by its leading term and order, meaning the number in front of the x is a positive number and the power is an odd number. So let's go look at the odd power first. Since it's odd, I think of the shape of y equals x cubed. y equals x cubed looks like this. If it had been a negative number out front, like negative x cubed, it would have this shape. Okay, so the 17 is positive. It's an x to the odd number, so it's going to look like x cubed. So as x goes to negative infinity this way, my graph goes down towards negative infinity. And as x goes to positive infinity out this way, my graph goes up to positive infinity. Number 5, find the zeros of the function and state the multiplicities. T of x equals negative 5x squared times x plus 1 times x plus 2 to the 4th. Luckily, this polynomial is already factored. To solve for the zeros, you would set 0 equal to negative 5x squared times x plus 1 times x plus 2 to the 4th. Now I need to set each of those factors equal to 0 and solve for x. So I get x equals 0, x equals negative 1, and x equals negative 2. So those are my zeros, 0, negative 1, negative 2. Now for the next part, find the multiplicities. I'm going to write the function down here again, negative 5x squared, x plus 1, x plus 2 to the 4th. Okay, 0 is a 0 of multiplicity 2 because the x squared, so 0 has a multiplicity of 2. Negative 1 has a multiplicity of, there's an understood power of 1 up there, so the multiplicity of the 0 is 1. Negative 1 has is a 0 of multiplicity 1 because of the exponent. Okay, for negative 2 is a 0 with multiplicity. If you look up here, you have the 4th power, so that multiplicity is 4. Number 6, determine if the graph can represent a polynomial function. If so, assume that the end behavior and all turning points are represented in the graph. Okay, the end behavior is up, up, right? How many turning points do we have? We are decreasing, and then we turn. We increase, and then we turn. We decrease, and we turn, and we increase. So there's 3 turning points. So that means that it has to be of degree 4. Remember, there's n minus 1 turning points for a polynomial of order n. Since there are 3 turning points, it's a degree 4. The graph does represent a polynomial. The minimum degree is 4. Okay, part 2. The leading coefficient. Okay, since the degree is even, the leading coefficient, did the graph look like again? Hold on. Okay, it's up, up, so it has to be an even degree. And since it's up, up, the leading coefficient has to be positive. Think about this way. Y equals x squared versus y equals negative x squared. So it's even degree because it's the same on both sides. It's going up, up. And it has to be a positive number out front. Part 3, approximate the real zeros with even multiplicity and odd multiplicity. All right, the zeros of this function. I have a 0 there at x equal negative 3. I have a 0 here at x equal negative 1. And I have a 0 at 1. This one crosses the x-axis, so it's an odd multiplicity. So odd multiplicity versus even multiplicity. Odd crosses the x-axis. Even touches the x-axis, remember? So because it crosses at -3, that's an odd multiplicity. It crosses at x equals -1, so that's an odd multiplicity. And it just touches at x equals 1. It comes down, it touches, and it goes back up. So that's an even multiplicity. All right, odd multiplicities are -3 and 1. So odd multiplicity, x equals -3, -1, and even multiplicity was 1. Remember, even touches, odd crosses the x-axis. Number 7, consider the division of two polynomials, f of x divided by x minus c. The results of the synthetic division process is shown here. Write the polynomials representing the dividend, the divisor, the quotient, and the remainder. All right. Dividend is represented by that polynomial. How do we write that out? That's the constant. We're going to put an x squared, an x cubed, and an x to the 4th. So the dividend is 1x to the 4th minus 7x cubed plus 8x squared plus 14x minus 23. That's the dividend. To get the divisor is out here, but that's not the divisor. The divisor is x minus that number. X minus 5 is the divisor. Okay, the third one is the quotient. The quotient is what you get after you do the division. So the quotient is going to be down at the bottom. Now remember, there's no x, there's an x squared, and an x cubed. Your dividend reduces by 1 degree when you get down to the quotient. Every time you do the synthetic division, you started with an x to the 4th, now you have an x cubed. Okay, so here comes the quotient. X cubed minus 2x squared minus 2x plus 4. All right, so we've done the dividend, the divisor, the quotient, and now we need the remainder. The remainder is this number here in the little box, -3. Number 8, divide by using synthetic division. Check your answer by multiplication. So when we do synthetic division, we've got to put it in the right order. We've got an x cubed, x squared, x, and a constant. So I need to write that -2x cubed minus 1x squared plus 33x plus 62. And that's getting divided by -3. Remember you said x plus 3 equal to 0 and solve for x. X equals -3. That's what's in your little half box. Now we go play the game. We drop the first number down. Then to get back upstairs, we have to multiply by the number in the half box. -2 times -3 is 6. And now we add -1 plus 6. To get back upstairs, 5 times -3 is -15. 33 minus 15 is 18. 18 times -3 is -54. And 62 minus 54 is 8. That's my remainder. Okay, I'm going to do different colors so I can put my x's in there. Nothing, x, x squared. So my answer will be negative 2x squared plus 5x plus 18 plus 8 over x plus 3. Don't forget the 8 is a remainder. You have 8 over the divisor, which is x plus 3. For number 9, divide by using synthetic division. Check by multiplication. Okay, I'm noticing that I have an a cubed and a squared, but I don't have an a. So when I go write my coefficients, I have 1a cubed plus 1a squared. I don't have an a, so I've got to have a 0 placeholder and then negative 80. Now I can check that. There's nothing. There's an a squared, a cubed. Is that right? 1a cubed plus 1a squared plus 0a minus 80. Okay, I'm good. I wrote my coefficients right. Now instead of writing a minus 4, I set it equal to 0, so a is 4. That's the number in my half box. Now the game. Drop it down. 1 times 4. 1 plus 4 is 5. 5 times 4. 0 plus 20. 20 times 4. And negative 80 plus 80. Oh, look, I have a remainder of 0. That actually divides into that evenly. Okay, be careful. This is in A's, not X's. So there's nothing behind the 20. There's an A and an A squared. So the answer would be A squared plus 5A plus 20. Just a reminder, when you're going down, you add. When you're trying to go back upstairs, you have to multiply by the half box whenever you're doing synthetic division. Question 10. Given f of x equals 4x cubed plus 9x squared minus x minus 6, answer the following. Factor that function given that negative 1 is a 0. Then solve when that function equals 0 and express answers in exact simplest form. Before I do this problem, I'm going to go jump over to my calculator and go to y equals and type in that function, 4x cubed plus 9x squared minus x minus 6. And I'm going to do a zoom standard, so zoom in number 6. Ooh, I see some zeros there. It told me that negative 1 was a 0, so if I hit second calculate 0, actually I don't want to do that. Hold on. There's my y equals. I hit graph. I'm going to type in negative 1. Nope. Trace negative 1 and hit enter. It tells me that negative 1, 0 is indeed a point on the graph. So negative 1 is a 0. I'm thinking maybe negative 2 is as well. And it is. Now, is 1 a 0? Nope. It's somewhere between 0 and 1, but I don't know what that one is. So I'm going to close my calculator down. I know that negative 1 and negative 2 are zeros. So let's go do my synthetic division. 4, 9, negative 1, negative 6. My little half number is negative 1. 4, negative 4. 5, negative 5. Negative 6, 6, 0. That's good. That meant that negative 1 was a 0. Now, with what's left, I know that negative 2 is also a 0. So let's go do synthetic division again. Bring down the 4, negative 8, negative 3, 6, 0. Good. I have 2 zeros now. Now what's left? What's left is 4x minus 3. Okay, so my factors are going to be x plus 1. I got that from this half box. X plus 2. I got that from here. And 4x minus 3. That was down here. Those are my 3 factors. Now it says to solve when you set that equal to 0. So if I set x plus 1, x plus 2, 4x minus 3, if I set that equal to 0, then I know x equals negative 1, x equals negative 2, or 4x equals 3, so x equals 3/4. So I get the solution set is negative 1, negative 2, 3/4. If I wanted to check that on my calculator, I can hit trace 3/4, and that is indeed a 0. Number 11, list the possible rational zeros of the function m of x equals 25x to the 5th minus 17x to the 4th minus 6x plus 10. Remember that the possible rational zeros are of the form p over q, where p would be factors of 10 and q are going to be factors of 25. So what are factors of p? 1, 2, 5, and 10. And factors of q, what goes into 25? Just 1, 5, and 25. All right, I'm going to write all of those p's over 1. So I get plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, plus or minus 10 over 1. All right, now I'm going to write all of those p's over 5. So I get plus or minus 1/5, plus or minus 2/5, plus or minus 5/5, which is 1. We don't need to do that because we already have it. And then plus or minus 10/5. Oh, wait a minute, that's 2. We already have that as well. So those 2 we don't need. I'm going to get rid of those 2. All right, last but not least, we need to write everything, all the factors of p over 25. So I get plus or minus 1 over 25, plus or minus 2 over 25, plus or minus 5 over 25, but wait, that reduces to 1/5 and we already have it. So I don't need 5 over 25. And then I've got plus or minus 10 over 25, which reduces to 2/5. I already have it. So I don't need that one either. So there's my answer. All of those numbers are possible rational zeros of that polynomial. Number 12, find all the zeros. It doesn't say possible zeros, it says to find the actual zeros. Since this is an order 3, I know I should have 3 zeros. So the first thing I'm going to do is go look at the graph. And for time's sake, I'm not going to reopen my calculator on this recording. I'm going to tell you that it passes through like that at x equals 1. And that's the only time it crosses the x-axis. So I know one of the zeros is 1. How do I go find the other zeros? Well, I'm going to do synthetic division. So here we go. Play the game. My coefficients are 1x cubed minus 5x squared plus 12x minus 8. Because I know that 1 is an actual zero, I'm going to put 1 here. When I play the game, I drop the 1 down. 1 times 1, negative 5 plus 1, negative 4 times 1, 12 plus negative 4, 8 times 1, and I get a remainder of 0, which is good because x equals 1 should be a 0. Okay, what do I have left down at the bottom? I have an x and an x squared. So I have a quadratic. X squared minus 4x plus 8. Okay, when does that equal 0? Can I factor that? And the answer is no. So I would go do my calculator and my apps and do the polynomials simultaneous 2 app and find out when does that equal 0. Or I could just use the quadratic formula. If you need a quick review on that, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So here we go. X equals negative b, so 4, plus or minus the square root of b squared, negative 4 quantity squared is 16, minus 4 times 1 times 8, all over 2 times 1. So I get 4 plus or minus the square root of 16 minus 32. 16 minus 32 is negative 16. The square root of negative 16, to pull out, get rid of the negative, you have to pull out an I. The square root of 16 is 4, so that's 4i over 2. So I get 2 plus or minus 2i. So my zeros are going to be 1, 2 plus 2i, and 2 minus 2i. Remember that complex roots occur in complex conjugate pairs. So the 2 plus 2i and the 2 minus 2i are conjugate pairs, complex conjugate pairs. Number 13, write a polynomial that satisfies the given conditions. It's a degree 3, so it has to have 3 zeros with integer coefficients, and zeros are 2i and 8/7. Well, if one of the zeros is a 2i, the other zero has to be negative 2i, and then you've got a third zero of 8/7. So you have all of your zeros. I'm going to write that as y equals x minus 2i times x minus negative 2i, which turns into x plus 2i, and x minus 8/7. Another way to do that one, because it wants integer coefficients, instead of writing x equals 8/7, multiply both sides by 7, and then subtract 8. So 7x minus 8 equals 0. That's your third factor, 7x minus 8. Okay, now I need to multiply this out. I get x squared plus 2xi minus 2xi minus 4i squared. But remember that I squared is equal to negative 1, so I can get rid of the I squared if I change the sign out front to a plus 4. Okay, I want that multiplied by 7x minus 8. Can I clean that first factor up? 2xi minus 2xi is gone, so I have x squared plus 4 times 7x minus 8. Now if I multiply that out, I get 7x cubed. Its first outer would give me minus 8x squared. Inner would be 28x. And last would give me minus 32. That's my answer. 7x cubed minus 8x squared plus 28x minus 32. Number 14. The graph of y equals f of x is given. Solve the inequalities. write the solution sets in interval notation. So for the first one, it wants to know, when is that function less than 0? Okay, when it touches this line, this x-axis, that's where it equals 0. Anytime it's above, so up here, this is where it's greater than 0. Down here is when it's less than 0. So it's asking, where is it less than 0? Here and here. What x values are those? That's going to be from negative infinity to negative 2 with a parenthesis because it can't be equal to 0. And then it's going to be from 0 to 4. That's where it's less than 0. Now it wants to know, where is it less than or equal to 0? Now we're going to make those into brackets instead of parentheses. So it's going to be negative infinity to negative 2 with a bracket, and then bracket 0 to 4 with another bracket. Now it wants to know, where is it greater than 0? I'm going to use a blue for greater than 0. So here would be greater than 0 with open circles, and then here would be greater than 0. So where is that? From negative 2 to 0, and then from 4 to infinity. Now, if you want greater than or equal to 0, you're going to fill those dots in. Those are equal to zeros. So instead of having parentheses, they're going to be brackets. So bracket negative 2 to 0 bracket, bracket 4 to infinity. Infinity and negative infinity always have parentheses. For number 15, solve the inequality. Write the solution set in interval notation if possible. Okay, I noticed that 4w squared minus 25 is a difference of 2 squares. That factors to 2w plus 5 and 2w minus 5. I'm going to set that equal to 0 and solve for w. So I get 2w plus 5 equals 0. 2w equals negative 5. W is negative 5 halves. 2w minus 5 equals 0. 2w equals 5, so w equals positive 5 halves. If I put those two numbers on a number line, negative 5 halves and positive 5 halves, I now have 3 pieces. Here's piece 1, piece 2, piece 3. Pick a number in each one of those pieces. For example, in the middle, I'm going to pick 0. Right here. If I plug 0 into my inequality, do I get a positive number or a negative number? Well, 4 times 0 is 0. 0 minus 25 is negative 25. That's a negative number. No matter what number I pick between negative 5 halves and 5 halves, if I plug it into my inequality, I'm going to get a negative number. Okay, let's go pick another number out here. How about negative 10? 4 times negative 10 squared minus 25. So that's 4 times 100 minus 25, 375. That's a positive number. Same thing happens if you pick positive 10. You're going to get a positive number. Now, your inequality, 4w squared minus 25, greater than or equal to 0. You want the pluses. You want here, equal to 0, equal to 0, positive. That's your answer. Negative infinity to negative 5 halves with a bracket, and then bracket 5 halves to infinity. Number 16, determine the vertical asymptotes of the graph. Give your answer as equations in exact form. Select multiple equations, separate multiple equations with commas if necessary, or select none if applicable. Your function is y equals 8 over t plus 5. To find vertical asymptotes, you set the denominator equal to 0. So t equals -5 is a vertical asymptote. Let me back up. You factor the numerator and denominator. If you can cancel common factors, those are wholes, but we don't have any common factors. So the equation of the vertical asymptote is t equals 5. Sorry, -5. Number 17. For the function s of x equals, the numerator is 3x squared plus 2x minus 5. The denominator is x squared plus 3. It says to find the horizontal asymptotes, if any. For horizontal asymptotes, you look at the degree of the top and the degree of the bottom. In this case, they're the same. So the horizontal asymptote is going to be y equals 3/1. Remember the ratio of the leading coefficients? So 3/1. So let's see. The graph has at least one horizontal asymptote. And the equation would be y equals 3. Now, if it has a horizontal asymptote, determine the point, or points, if any, where the graph crosses the asymptote. So if we set the y value equal to 3 and solve for x, what do we get? 3 equals 3x squared plus 2x minus 5 all over x squared plus 3. I'm going to multiply both sides by x squared plus 3 so I can get rid of the denominator. So I get 3 times x squared plus 3 equals 3x squared plus 2x minus 5. On the left, I need to distribute, so I get 3x squared plus 9 equals 3x squared plus 2x minus 5. 3x squared, if I subtract it from both sides, those cancel. So now I have 9 equals 2x minus 5. Add 5 to both sides, so 14 equals 2x. Divide both sides by 2, I get 7 equals x. So the point where that graph crosses the horizontal asymptote is going to be x equals 7, y equals 3. So if I were to graph this function, here at y equals 3, I'd have this horizontal asymptote. And whatever the graph looked like here at 7, 3, it would cross that asymptote. You'd have a point there. Number 18, graph the function by using transformations of the graph y equals 1 over x. Plot all necessary asymptotes. For the vertical asymptotes, make sure there are at least 2 points on each side. So you have the function y equals 1 over x plus 4. It looks like y equals 1 over x, which is this graph. But it's been shifted. The x plus 4 means that it goes to the left 4 units. All right. Instead of having an asymptote, it didn't pick up the new color. Having an asymptote here on the x-axis, it's going to be shifted left 4. So it would be here. I'm not shifting up and down, so my horizontal asymptote at 0 stays. Now, I don't know if you can pick it up, if they give you the y equals 1 over x and you just pick it up and move it, or if you have to go plot points. If you have to plot points, you need to pick 2 points to the left of -4 and 2 points to the right of -4. So let's go pick -6 and -5, and then maybe -3 and -2. What are my y values? They're going to be 1 over -6 plus 4, which is 1 over -2, 1 over -5 plus 4, 1 over -1, which is -1. 1 over -3 plus 4, which is 1. And 1 over -2 plus 4 is 1/2. So here are my points that it would graph. -6, -1/2, -5, -1, -3, 1, and -2, 1/2. So it should draw that graph for you. Number 19, for the graph, you've got f of x equals x minus 3 times 3x plus 5 over 3x plus 4 times 3x minus 2. Find the x-intercepts. X-intercepts where the numerator equals 0. So we've got x minus 3 and 3x plus 5. Set them both equal to 0, solve for x. 3x equals -5, x is -5/3. So for part A, the intercepts are going to be 3, 0, and -5/3, 0. Those are 2 points. Okay, vertical asymptotes. You would cancel common factors, but there's not any. And then to find vertical asymptotes, set the remaining stuff in the denominator equal to 0 and solve for x. 3x plus 4 equals 0, and 3x minus 2 equals 0. 3x equals -4, x equals -4/3. 3x equals 2, x equals 2/3. You have 2 vertical asymptotes. They are x equals -4/3, x equals 2/3. Okay, I'm going to get rid of some of this color stuff, so hang tight. Okay, for the horizontal or slant asymptote, you got to find the degree of the top and the bottom, which means I need to multiply this stuff out. So if I multiply the top out, I would get 3x squared plus 5x minus 9x would be minus 4x minus 15. All I did was FOIL the 2 binomials in the numerator. Do the same thing on the bottom. 3x times 3x is 9x squared. Minus 6x plus 12x is plus 6x minus 8. Okay, the degree of the top is 2. The degree of the bottom is 2. They're the same. So my horizontal asymptote will be y equals the ratio of the leading coefficients, 3 over 9. And 3 over 9 reduces to y equals 1/3. That's the horizontal asymptote. If there's a horizontal asymptote, there cannot be a slant, so that's going to be a none. Last but not least, the y-intercept. To find the y-intercept, let x be 0. So I get 0 minus 3 times 0 plus 5 over 0 plus 4 times 0 minus 2. Well, that's -3 times 5 over 4 times -2. -15 over -8 is going to be 15/8. So as a point, my ordered pair will be 0, 15/8. Number 20. The graph of the function is given. Solve the inequalities. Write it in interval notation. All right. Remember, this is where it's equal to 0 on the x-axis. The first one is asking where is it less than 0. So we want to know where is it below, less than 0. Okay, can't be equal to 0, so I'm going to go put open circles where it equals 0. Where is it below the x-axis? All of these x values, it's below the x-axis. And then all of these are below the x-axis as well. So what x values would that be? Up to the asymptote and all over here. All of those are below the x-axis. So for part A, my answer would be negative infinity to 3. And then from, what is that, 4 to infinity. Okay, I'm going to erase the stuff on the graph. No, I'm not. Okay, for part B, the only thing that's different is that it's less than or equal to. So wherever we have the open circles, I'm now going to fill them in. No, can't fill in the asymptote. It's always open, remember? But I can fill in that 4. So the answer to B would be negative infinity to 3, still a parenthesis because that's a vertical asymptote. Union 4 is a 0, so I'm going to include it with a bracket to infinity. Okay, now I'm going to go erase the stuff on my graph. All right, now for the next part. It wants to know where is it greater than 0. So we have to put, here's the greater than 0. I've got to put an open circle at the asymptote and at the 0. Now, where is it above the x-axis? Where is it greater than 0? Well, that's this part of the graph, and that only occurs here between 3 and 4. So my answer for part C is just 3 to 4. Now, if we include the equal to, greater than or equal to 0, it's equal to 0 right here at 4, so that gets colored in. You still can't color in the vertical asymptote, so it's going to be an open 3 to a closed 4. The last one, solve the inequality. It's a rational inequality. So we need to set the numerator equal to 0. So I get 4 equals x. And the denominator equal to 0. So x equals negative 5. I need to put those on a number line. Negative 5 and 4. Now, because the negative 5 was in the denominator, that's always going to be an open circle. That's a vertical asymptote. Because it's greater than or equal to 0, I'm going to put a closed circle on the 4. Now I need to go pick numbers in each of those pieces. If I pick negative 10 and plug it into my inequality, do I get a positive or a negative number? 4 minus a negative 10 over negative 10 plus 5 gives me 14 over negative 5, which is a negative number. If I plug in 0, I would get 4 minus 0 over 0 plus 5, which would be 4/5. That's a positive number. If I were to plug in 5, I would get 4 minus 5 over 5 plus 5, which is negative 1 over 10. That's a negative number. Now, on my inequality, I want greater than or equal to 0. Greater than means positive. Greater than or equal to 0, those are the positive ones. So I want this piece. So my answer would be negative 5 with a parenthesis to 4 with a bracket. And that's the end of exam 2 review. I hope that you're working this through one time using notes and maybe possibly this video, and then you work it through again using only your brain. If you're using only your brain and you're getting the answers correct, then it looks like you are ready for exam 2. Good luck.